So let's begin without any further ado. Good evening, one and all who have gathered here. And so the first question in the poll was, are you familiar with IoT? To which 67% of you answered yes, and the other answered no. Okay, so that's good. And do you know what is indoor farming? Here we have a tie. I mean, there is 50% who have answered yes and 50% who have answered no. Let's begin. So today's agenda is basically I'll just discuss and touch on the topic of indoor farming and just tell you what is indoor farming a bit about. So the other 50% who have no clue will at least have an idea. And we would discuss the working schematics and the design of my project. I hope you all have seen the YouTube video. So it is just IoT monitoring system for a indoor farm. And then I'll also explain the code for both the Arduino and Bold Cloud. After this, I will tell you further modifications that you can do to the system and kind of make it add more features in it, and also what are the different ways by which you can work around it. So for those 33% who are not familiar with IoT, just a small brief introduction. IoT stands for Internet of Things. So it basically means that things or devices, they communicate to each other over the internet. So for example, maybe it could be your refrigerator communicating with your smartphone over Wi-Fi, or for example, even your Amazon Echo, and you have all these smart light bulbs. These are controlled by voice, and these are interacting over the internet. So these connection and these devices are called Internet of Idea. When implemented in indoor farming, gives out the IoT-based indoor farming systems. So indoor farming is a type of farming where you grow crops indoors or restrained inside a closed environment. And they are usually vertical farming, as in they are farmed in stacks. Unlike traditional farming where you have a huge land, huge plot, and you farm on that plot, here you just farm them in stacks, or you farm them in kind of rows and columns. So this allows to reduces the area in which you are farming, also increases the produce per area. So assume if normal 1 hectare you are able to produce more than 1 quintillion of wheat. Using indoor farming, you can multiply it further racks. And because it is indoor farming, you kind of control the whole environment in which the plant grows, because there is no sunlight, there is no rain, there is no wind blowing, or there is no heat, or there is no cold of the environment which affects. So you kind of grow it in a very sterile, very closed environment. And to control that environment is very important. If any one of or two of the parameters don't fit, so the plant may die. And it is quite very difficult because growing plants is very time consuming, as it may take around 3 to 4 weeks just to get it matured, and another 3 to 4 weeks to make it. Compared to traditional farming, it is more quicker to produce crops because 24/7 light is available and all these things. And the main aim of indoor farming is to like optimize the plant growth and avoid soilless farming techniques. By avoiding soilless farming techniques, you are able to avoid pests, and you are able to deliver the nutrients and the water very quickly and efficiently. So again, you can grow them in buildings. Some people grow it in shipping containers, and many of them have started growing them in abandoned mine shafts. Why mine shafts and tunnels? Because heat is very important. It has to be warm and temperate climate. So the heat from the earth allows the mine shaft to heat up. So you don't need to have to provide additional heating. So that initial heating of the earth is sufficient to grow the plants. Like I told, you have a lot of indoor farming done wherein you have a lot of stacks. As you can see, many of the crops are grown in trays, and each tray is kind of barcoded. So you have a barcode on each tray which grows the plants. They put in saplings and they allow the plant to grow. Water is provided continuously, air is checked, the temperature and humidity is checked for a favorable environment, and light is provided. So with this, the growth cycle is almost twofold. Hope now you have a clear idea of indoor farming. Again, what are the advantages and disadvantages? Advantages is that it is quite sustainable and allows for much more local production. So places like cities where they don't have a lot of farming land, it is more easier to just get some warehouse and start farming them. So the produce is locally available. You don't need to spend a lot of money and resources transporting them or packaging them. And also you can repurpose old infrastructure. So any building which was is about to be demolished can be just renovated with basic and just provide a shelter. Again, the disadvantages is because it is quite a new upcoming technology. Economies of scale do affect. So there is very quite a sweet spot to earn profit. If you go very less, you may not earn more. And if you go very high, I mean, you build a very huge farm, again, you may end out in losses. Again, it is also energy intensive because you're using electricity for lights, you're using electricity for the sensors, you're using electricity for watering and other systems. So yes, there is a bit extra for electricity usage. Energy, it is very intensive in energy. However, if you couple it with green energy like solar panels or wind energy, then it is completely carbon free. Also, there are few technological limitations currently, which I mean, it will take time. Maybe once people start accepting the idea, then it will definitely increase. So basically, what are the parameters that you can control? Well, you can control the temperature. That could be the temperature of the air or the nutrient that you are providing, or else the plant temperature itself. Again, you can control the humidity. You can control the amount of light, what kind of spectrum, like what color of light. As you can see, many of the colors are red and purple, but also there are also other wavelengths. You have white, you have cold white, you have warm white, and different other spectrums available. Also, another important thing is to maintain the carbon dioxide level. So you have a lot of carbon dioxide being taken in and oxygen being putting out. So you need to maintain a constant supply of carbon dioxide for the plants to grow. And then you have your nutrient concentration. Again, you can just get water sensors to adjust the nutrient concentration on different pumps. And you have nutrient pH. Basically, it is just checking the pH value of the water which is being supplied. And pests. Well, for our system, and if you are planning, if you want to build your own, getting a temperature, humidity, and light is more than enough. And your plant can definitely survive on these three itself. Components required: a Bold IoT module, an Arduino Uno, or a Nano or a Mega. Anything is fine. I've worked with all the three. All the three work well. Next is your DHT11. This is a humidity and temperature sensor. So this sensor gets the humidity of the enclosure as well as the temperature itself. So by this, you can measure the temperature and the humidity of your enclosure. Next, you would require a soil moisture sensor. The soil moisture sensor will measure the amount of water content present in the soil. And if it is too dry, then it will give out a signal and you can write a code so that it turns on the water pump. Similarly, there is also an LDR sensor module. Well, this is completely different from a LDR, which you may have been seeing, which is just only the front photoresistor part. This whole module, why I would suggest is because it gives a direct output and does a lot of logical work for you. So your code becomes quite simple. And then also you can directly power it with your 5 volts. You don't need to add resistors or you don't need to add or a voltage divider just to get the output. So this kind of helps in easy plugging in and troubleshooting your project. So LDR is just to get the amount of sunlight, if sunlight is present or not. And then a 4-channel relay or else you can just use three single relays. Anything is fine. A 4-channel relay, so it is controlled by Arduino, and you can power on any kind of appliances. These two constitute your microcontrollers. These three constitute your sensors from which you'll get your input. And 4-channel relay is basically your output controlling these three outputs. Your DC fan, there is a 12-volt DC fan to allow air coming in and out, to push the warm air or the humid air outside the enclosure, calling in fresh air. So you want to have pressure which is sending the air out rather than, forcing the air in. So it is better to have an exhaust fan rather than an inlet fan. Then you have your 12-volt grow LED lights. Again, not important be it grow LED lights, but you can even have your normal LED lights as well, which you get 12 volts for your decorations or all that. Even those work very well. And you would require a 12-volt DC water pump. Well, there are also other water pumps like your 5-volt water pumps. However, the discharge rate is very less, as in the amount of water that it pumps out is very less. And also they are quite prone to failure. I mean, I myself have gone through almost 5 to 6 water pumps. So I've stopped using ever since. And 12-volt DC water pumps work fine. They are quite readily available and you can just find them easily at a local electrical store. Additionally, just few connecting wires and breadboards to build your whole setup. So these are the components required. Another thing is to ensure that you have a separate 12-volt power supply for all the 12-volt supply things. You don't need to have a common power supply for the bolt and sensors as well as these devices. These three devices, your DC fan, these LED lights, and the water pump should run separately on one 12-volt adapter, and the rest could be connected to your laptop or any other power supply, or even your phone charger as for that matter. Well, the design. So this is just a basic explanation of how the data flows and what is the flowchart. So you've got your Arduino, which is the main microcontroller and would do the whole monitoring as well as controlling. Bold IoT is just a place to view your data through anywhere or any part of the world if you're in. If you just want to view it, Bolt Cloud is the method. Otherwise, every kind of calculation, measuring value, as well as sending out outputs is done by your Arduino microcontroller. To this, you have THD11, which sends in temperature, humidity. Arduino processes it and sees if it is within the environment, within the comfortable range. So if the temperature is above 35 degrees Celsius or your humidity is above 75%, so then it sends us relay. It tells the relay to turn relay 1 to turn on, and the relay 1 powers on the exhaust fan. This exhaust fan sends out the humid air or the hot air out, bringing in fresh air. Because of the negative pressure inside the enclosure, fresh air comes from the outside. So over time, slowly the temperature also reduces or the humidity will also reduce. Once the humidity is below 75 within a favorable range, or the temperature has fallen below 35, the fan switches off and that environment is maintained unless and until again it reaches. So it is almost like a thermostat. Similarly, your LDR is used to detect any kind of sunlight. So if your room is well ventilated and you have good amount of sunlight coming in during the day, the device will detect the sunlight and the LDR will detect the sunlight and send it to Arduino. Arduino will then determine the amount, should it on or off the grow lights. If the sunlight is ample, then the LED lights turn off. If not, for example, if it is night time, then or else you have closed your doors or the room is quite dingy, the Arduino tells the second relay to turn on the LED lights. Similarly, you also have your soil moisture sensor. If the moisture is less than 15%, then it turns on the third relay, and the third relay in turn ons the pump. Then the pump forces water into the system, and over time once it crosses 80% limit, like if the soil is moisturized 80%, then it stops. So this is just a basic simple design. And all these four values, that is your temperature and humidity from DHT, your ambient sunlight from LDR, and the soil moisture from the soil moisture sensor, all these four values are then sent to Bold over the UART connection to the Bold, and the Bold itself sends it to the cloud. So using your smartphone or using your laptop anywhere, you can just log into your project page and monitor your farm. So in this way, monitoring is also being done as well as controlling of the farm is being also done. So working, basically, what are the conditions? So if the temperature is greater than 35 or the humidity is greater than 75, it should enable the exhaust fan or else turn off the exhaust fan. Similarly, if sunlight is absent, it should turn on the LED lights. If sunlight is present, then it should shut down the LED lights. And if your soil moisture is less than 50, it should enable the water pump. So this is just the basic working and conditions for controlling. So now this is your schematic. Again, no worries. I mean, it may look too complicated or a lot of wires, but it is just almost, you have 8 to 9 wires going on, not much. Most of them are just power wires for the relays and other things. As you can see in this schematic, to your left side, you have your whole microcontroller. For the relays, have a separate power supply. So I'm running my Arduino, my Bolt, and my device and my sensors on 5 volts. And there is a 9-volt power supply. So it can be a 9-volt battery, or else you can have your phone charger which outputs 5 volts. And it can be plugged to your Arduino. So Arduino gets all the power, and from there 5 volts is distributed to your Bolt, to all your sensors as well as the relays. Have a separate power supply. So there is a dedicated 12-volt power supply to run your exhaust fan, your LED lights, and your water pump. So you can have just a 12-volt adapter, which is quite frequent these days. Many devices at your home run on 12 volts. Any one of them can power all these things. So 12 volt, 1 amp is more than enough. 12 volt, 2 amps is fine. Coming to wiring, you have the TX and RX pin of your board. Again, you connect 5 volt and ground, VCC and ground to 5 volt and ground pin of your Arduino Nano. Connect your 5 volt and ground of Bolt IoT to 5 volt and ground of your Arduino Nano, 5 volt and ground of LDR to the 5 volt of Arduino Nano. Similarly for DHT11 and soil moisture, 5 volt ground. Now comes your TX and RX pins. So the RX pin is connected to pin 9 of the digital pin 9 of your Arduino. And the TX pin, that is your green wire, is connected to pin 8 of your Arduino Nano. You don't connect it directly to your TX and RX given, because if you connect it directly, like if you have built any project using HC05 or any kind of TX UART connection, you directly connect it to 0 and 1. You should not connect it to 0 and 1, because 0 and 1 is by default being used by your computer to upload code. So if you connect your Bolt IoT directly to 0 and 1, the TX and RX pins to TX RX pin of Arduino, it would be very difficult for you to upload the code, as the pins are occupied by Bolt and the computer can't connect to your Arduino using those pins. So I used a software serial and I converted these D8 and D9 to TXRX. So I mean, this is one connection. Similarly, because you have 3 relays, you would require 3 digital connections. The 3 digital connections are your D4, D5, and D6. So the 4th, 5th, and 6th pin, digital pins, 4, 5, 6, get connected to each relay. So each one of the relays are used to control your fan, light, and pump. So you can change it according how you have wired. Additionally, your DHT11 would be connected to pin 2, and your LDR module would be connected to pin 3. So with this, you will get digital inputs, and because you are using header file for DHT, it will directly give you the temperature and humidity through one wire. You don't need to bother. LDR again, if you are connecting to D3, it will just give you output in the form of 0 and 1. 1 if there is no sunlight, and 0 if there is sunlight. I mean, it is quite opposite in this. Again, that depends on what kind of LDR you have got, because a lot of Chinese knockoffs have different working, and 1 for sunlight being detected and 0 for sunlight not being detected. So you have to see according to your LDR. And you have your soil moisture sensor connected to your analog pin. Any of the analog pin is fine. So all you need to is the schematics will be shared. Now explaining the Arduino code. So I'll just share the Arduino code. Okay, great. So the Arduino code is visible. Thank you. So straight away to begin with, software serial, a header file to convert any two pins to TX and RX. So here I have converted pin 8 and 9 to TX and RX, and I've connected pin 8 to RX of Bold and pin 9 to TX of the Bold. And so this is a header file for creating UR pins. Next, you have your header file for your DHT11. I did not use the bold header over here. Initially, when I was building it, I was on a time. I was in a time crunch, so I didn't use the header of bold. Instead, I just got some code from elsewhere, which avoids the use of header file. Yes, it is Arduino IDE, and it is connected on pin number 2 of the Arduino Nano. Similarly, here it basically initializes the type of sensor as well as to which pin it is. It initializes the DHT sensor, so DHT11 to pin number 2. And coming to next is just this is initializing the LDR, telling that LDR is connected on pin 3. And then this is to tell that the fan relay connected to the fan is on pin number 4. The relay connected to the light is connected to digital pin 5, and the water pump relay is connected to pin number 6. So rather than I having relay 1, relay 2, relay 3. So coming to setup function, this function usually run once. So again, you initialize the serial begin. The serial begin is for your computer. So when you open your serial monitor, like Control Shift M, again, there is nothing connected yet, so it has shown this error. So it opens your serial monitor. My serial is the bold. My serial is basically the bold serial which is being connected. DHT, beginning the DHT. Here I kind of set in. So the pin mode, DHT pin is an input and the LDR is an input device, as well as the relays, fan relay, light relay, and the pump relay. These three are the output. Now comes the string data. Basically comes the loop function. So this is basically the function which runs the whole code and gets all the sensor values, compares it, turns on the respective devices, and then sends it to board. So basically string data, initializing data, a variable name data of string data type. I have an LDR out, basically an int. Similarly, int hum is basically a variable which stores the humidity, which it got from DHT. And temp is a variable which stores the value for temperature, which it got from DHT. Now here is basically what conversion comes. So now this section is for your turning the light on and off. So now if LDR detects any sunlight, if it detects any sunlight, it shows low. When sunlight is detected, it shows low. And I want the relay to be turned off. I don't want the light to be on. So here it will turn off the lights. Here if sunlight is detected, it turns off the light, else it will turn on the light. So till here is what you have your LDR. This is basically to turn the light on and off. It gets the LDR reading. If it is low, if the sunlight is detected, it turns off the light, else it turns on the light. So you have solved your criteria to turn on and off the light based on sunlight. Next, we have your fan, to when to turn on and turn off the fan. Now, if the humidity is above 75% and the temperature is above 35 degrees, the fan will turn on. Else, if it is less, if none of the conditions satisfied, here I've kept a or statement. If any one of these is satisfied, good. If not, it will turn off the fan. Now you have even completed your second constraint of maintaining the air temperature and humidity. You have completed maintaining the light criteria. Next comes the moisture. If you read the moisture sensor, it will give an analog output. So analog read at pin 0. This basically reads the analog value from sensor at pin A0. So it reads the analog value from pin A0. Now here there is a bit problem, because assume that if it is 100% filled, your output would come as 0. And if there is no water, 0% moisture, it would show as 1023. If the moisture is greater than 869, so 869 would be 15%. Hope you're understanding. So 100% is 0, 15% is 869, 0% is 1023. And if the moisture is less, I mean if it is between 15% and 0%, the water pump will turn on. Else it will turn off the water pump. No worries about the code. It would straight away work if you have done your connections properly. You can just straight away copy the code from GitHub, download the INO file, plug your Arduino, upload the code, and it would work straight away. No worries. If there is any errors, you can, I think, troubleshoot it. Now, so far we have completed all our constraints. That is, we were able to turn on and off the light, we were able to turn on and off the exhaust fan, and we were able to turn on and off the water pump. Now comes the important part wherein we kind of upload the code to Bold IoT. So because I have not used the Bold IoT Bold header file, I have used some other code. Basically what happens is, there is, after every 5 minutes, the Bold IoT sends RD. It sends RD as a string value. So if your device is connected, I will explain further how to set up your Bold IoT device. So when it is connected to Arduino, it will send RD after every 5 minutes. And so this function over here is basically an upload function to the Bolt. It is first, this if condition is just to check if Bolt IoT is connected. If it is connected, okay. If it is not connected, it skips all this. So then I have created a new string called read data, and this read data is basically to get a command from Bolt. And once it gets this read data, it will try to check in this read data, like the message that Bolt has sent, the command that Bolt has sent, and it will try to check RD. If the Bolt has sent RD, then it will upload the values. So here you have a string upload. The string upload is basically an upload variable of string data type. In this, I have stored, it stores the CSV value in form, it stores all the values in form of CSV. So you have your temperature, comma, humidity, comma, LDR out, comma, and moisture. So your message would go as 35 degrees Celsius, comma, humidity 70%, comma. LDR out, it can be 0 and 1. Let us say 0 for no sunlight, and moisture, let us say 80%. So this is what the CSV values will be sent. And Bolt would take all this CSV values and convert. And on the Bolt side, we would write a code that this is your temperature, this is your humidity, this is your ambience, and this is your moisture. And then this code is to send this message. This is basically the creation of string data, creating the string message. And here we are sending that message. And once it is sent, we just even show it in the serial monitor. So this is just another way of working around with Bold IoT. I did face few issues, but again, it was rectified. But because I was that time in a hurry, I used this method and it works. So I hope you are clear with the with the Arduino ID code. Well, the reading occurs continuously after a delay of 1 second. Here there is a delay of almost a 1 second, but the Bolt IoT will only gather the values after every 5 minutes. There is no way you can ask the Bolt IoT to get it after 30 seconds. It is done by the Bolt IoT at software side. So now I would explain the Bolt IoT. So now coming to the Bolt IoT, how you can set up. Firstly, you need to go to your Bolt IoT cloud. Hope you're able to see the cloud page. If so, can you please say yes in the chat? Is the Bolt project? Okay, great. Thank you. So now we have come to your cloud Bolt IoT page. So if you have a Bolt device, obviously you would have got your cloud access. Open the cloud and click on add product and click on create a new product. So here you can give whatever name. So I would just say indoor farm. And here you would need to choose click on input devices and you would have to click on UART. So you have to click on input devices and click on UART and you click on done. So now after this is created, you can go and click on configure this product. So here you can click on hardware and here you can see how many CSV values do you want to send. In our Arduino, we sent 4 values. So we will choose here 4. You can send up to 6 values. So we'll take 4 values and as you can see here, you have got them. So then you have to choose them based on the order that you have received. So if you remember, the first was temperature, second was humidity, third was ambience, matlab your sunlight, and the fourth one was your moisture. And as you said, 30 seconds is only available for Bolt Cloud Pro, and you can only do for 5 minutes. So 5 minutes is fine. So 5 minutes, and these are your CSV values. And then you click on save. Again, don't mind if it is going very fast. All the steps, all the procedure, every step will be shared to you in your mail, as well as the link will be shared where you can get the guide. And once you get it, you can start writing the code. So here you'll have to write the code in JS. I have already written and I'll just share the code. Code again will be shared, no worries. I'll share the GitHub repository. You can download it from there. So the code is written in JavaScript. Hope the code is visible. If it is visible, just say yes in the chat. So basically, this is a very simple code. First line, set chart title. It is basically telling your cloud website in Bold to have the name Intro Farm Monitor. That is the name or title of your page or the cloud page. Second, on lines 3 to 6 is basically you create a line graph. So you are creating a new line graph which will show the temperature and the time. So you are plotting a chart between timestamp. Timestamp is basically getting the current time from the internet and the temperature. So your temperature value is your CSV0, which you got from Arduino. So there is a first graph being plotted between your temperature and your time. And then you have your, similarly, the second graph, you have your time and humidity. Third graph, you have your time and sunlight. And the fourth graph is your time and soil moisture. So if you click on save, and now here is what all the graphs are. So your first graph is your temperature. Temperature is being showed about 32 degrees. Your humidity is around 40%. Sunlight, yes, there was sunlight 1. And soil moisture, almost, it will give you a new data point. One more thing to be very careful, don't keep on pressing push data to cloud, push data to cloud. Most of us would be having, what do you say, not a pro account. So if you complete 20 clicks within 5 minutes, before 5 minutes you complete or press this 20 times, you kind of get blacklisted by the cloud server and you get banned for almost 6 hours. This is how you build your whole Bolt IoT indoor farm. I'll just show you a simulation. I hope you can see this setup. So again, a top-down view. So I repurposed it out of an old CPU case, and when I had built it, it was proper lockdown. I couldn't get a proper case to be manufactured. A CPU was lying around, so I built it around a CPU. I have an LCD connected to it, which shows me all the values, and I've got a humidity and an LDR module to show the sunlight. So as you can see, you've got LED lights. These are your grow LED lights. Because it is very dark, these LED lights provide ample sunlight for as a substitute of sunlight to the plants. And I have connected these DC male and female. So this whole part becomes easily removable whenever you want to harvest your crops. So it makes it much more easy to remove and replace. Putting this aside, I hope you can see the setup. I've got my soil moisture over here. I've got my exhaust fan. Then I have all my sensors over here. I've got the VHD, I've got the LDR module. And if this is my console, so this is I am running it on a Arduino Mega as well as a Bold IoT. Hope you can see the green and blue lights. So assuming if the exhaust is too hot, I mean temperature is too hot, if I blow air or humid air, so the humidity has come 73 and the fan has turned on 75, and over time it reduces. The soil moisture sensor also detects. The water pump I have removed, kept it separately because as I'll be opening, make proper connections, avoid anything being open so that it may get shorted. This is your setup. You've got a fan. The relays are connected at the bottom. I hope you can see the relay section here. Behind is just a rat's nest of wires. You've got your power distribution, Arduino Mega on top, as well as Bold IoT. Again, this is just a test bench setup which I've created for common projects which I have built. And so this is my whole project. As I've told, this is my DC jack for your lights. So it is easily removable. I can easily remove and keep them aside. I hope the video demo is clear. So again, I'd explained the Bolt IoT product. So the output also I've just shown the video right now, just a small simulation. So further modifications, how can you modify it as per your requirement? Obviously, I was like short on resources, so I just built it around the CPU repurposing an old CPU case. However, you can get your own custom design done. I have few designs which I'll share it. So here are few designs which I've seen over the internet and got few inspiration. You can have an Almara kind of a design wherein you can have two stacks. This is like almost a cupboard and you can have two stacks. And this here is a very small cube. So it is almost a 30 by 30 centimeter cube in which you can just grow almost 4 to 5 plants. I've devised the same CAD file. You can just, if you have a 3D printer at your college and they allow you, or else you have something accessible, you can build, or else even you can build out one with wood and any material, cardboard, whatever is fine with you. So you can have different designs, some of the unique designs which are shared here. Next, you have an Android app. I kind of built my own personal Android app in which I have best of both worlds. So there is, if I click on Bold, it will open this page and there is a inbuilt web page inside. I mean, there is a web viewer inside in which I can directly open. So I don't need to have the Bolt IoT app with me, or I don't need to go on to Google Chrome or any kind of browser which you use and type in the login. I can just open my app, click on Bold, and it opens the web page. All the features are available. If I click on device, by this I can connect over the Bluetooth. If I'm using a Bluetooth, I can use Bluetooth and get more details precisely. And I can get the CO2 concentration. So for CO2 concentration, you can use a MQ2 sensor, MQ3 sensor. It gives you the CO2 concentration. And then here also I can manually myself turn on and off the exhaust fan, the indoor light, and the water pump. Again, this doesn't use Bolt IoT, it connects via Bluetooth or Firebase, any one of these. And it also tells me whether if it is on or not. So by here I can even get the cloud data as well. So, and the journal is basically to keep notes or track when you have planted your plants, how long will they grow, or else when I have to harvest them. So it is basically a small calendar. Settings are just basic app settings if you want to dark mode or anything else. So this is another way you can create apps for your project and make it more personalized and quicker to access. Similarly, you can add NRF module as well as Raspberry Pi. So basically radio modules, you have NRF modules. On the video, you can see these two. This is your farm setup, and to which you have your Arduino, you have your CO2 sensor, you've got DHT11, you've got your sunlight LDR module, and this sends it over to the radio frequency. On this side, I've got a router, which is an Arduino Nano, and you've got a Bluetooth module. So I can connect my app to this Bluetooth module, or else I can even connect Bolt IoT module directly to it, and I can share it. So why would I use an RF module? Why should I use RF module is because if I have to use 2 or 3 different farms, if I'm having 3 different farms, and all of these 3 can be connected similarly to one, and the maximum distance between them can be 800 meters. So assuming if you are in another room, or else if you are in another house, or you are on the first floor, you stay on the third floor and your farm is on the first floor, you can kind of control and monitor it without putting a Wi-Fi router at your ground floor or putting it in your basement or putting at your parking, wherever. So RF, you can connect multiple to one Bolt IoT module. So you can connect almost 3, 5, however, connect the Bolt to Arduino and write a code for the Arduino to get all these values. Again, if you wish, I would share these details also later how to make them. And you can even connect Raspberry Pi, run Python programs, run anomaly detections. So Bold IoT is what I have built it with, and I'm just explaining that for now. So to conclude, this is just how you can build your own personal indoor farm and have it IoT enabled. You can use IoT for monitoring as well as controlling the environments. And as I've shown the few previous modifications, you can have these modifications as per on your requirement. So if you can build it, you can obviously modify it for your own plants as well as what you're growing. And why this, why not that? Many of y'all would be having the question, and I can see the spam. Why not this? Why not that? Again, it is completely based on person to person. Whatever was available to me and whatever was my requirement to present, I have just presented. Apart from that, would just make it complicated and would lose the interest. So that is why. And well, almost it's been an hour that I've been talking. So just I would conclude this session by sharing my Bold experience. So I have purchased the Bold. I purchased my Bold IoT module like 4 years ago when I was in my first year of engineering. I did my mechanical engineering, but I recently completed my certification in the lockdown. Again, because of college, I never got proper time to complete my Bold certification. However, I used my Bold IoT for a lot of projects, a lot of hackathons. And the reason I loved Bolt was because it is very small. It is very cute in a very cute and small package. So it is very easy to carry around and put it in projects. And another thing is very easy and seamless setup. So normally if I'm building a project for hackathons or any project for competitions, it takes a lot of time to set up Google Firebase, to set up an own app, or to set up the Arduino, make sure the connectivity is done. But with Bolt, it is just plug and play. Code is to be uploaded and ready to go. So it is very easy to set up. Website is already there. And very obviously, because everything is already pre-built, very short build cycle is there for your projects. So just a few projects which I had built, small personal test bench of mine, my major project where I had built a custom solar oven, again monitoring done by Bolt IoT. And additionally, because I was using my Bolt, I also got a 3D printed case for it. So this is what my experience has been with Bolt, and I would also take this opportunity to thank Shobit, Ashwin, as well as Akshayan, who are the Bolt IoT moderators and who had contacted. So thank you for having me on board and sharing my experience and my project. Okay, so this is where you all have been, bugging in the chat. Here is your QR code. You can just scan these QR codes to get the Hackster IO is basically the guide where I had built the whole project. You can just scan and go to the web page. You'll get everything, the code, the wiring schematics, everything there. YouTube video, if you want to see the YouTube video of me explaining the process. If you're not comfortable reading, YouTube videos available. GitHub repository to get the GitHub files and the files code for Bolt and the code for Arduino. And additionally, if you want my CAD files, you could go to this website. So I hope the QR codes are visible. And again, I'll just wanted to say thank you all for, having me here and listening to me patiently for the past 1 hour, and hope you really learned something new about indoor farming and felt quite innovative or something unique about this. Now the floor is open for questions and the moderators will be unmuting you so you can start asking questions. I'll just put on the page back for this. So any questions? You all guys can just chat. I'll start. Okay, so what is the basic cost of this project? Basic cost varies from person. For me, it finished under 5 to 6K because most of it was readily available. For 6 to 7K, you can build it. Can we develop hydroponics farming with Arduino? Yes, you can develop a hydroponics farming with Arduino, but you'll have to use multiple relays and add flow rate sensors. So that is where you can reach a hurdle, is basically finding an appropriate flow rate as well as relays. So you'll have to work a lot with pumps and motors, but it is you can easily develop. Where did you learn indoor farming before implementing technology to it? Well, I had visited a couple of indoor farms, and where I stay, there are few startups which have really started selling indoor farming kits. So that is where I kind of saw them, and because it has already started becoming a business, I worked on one too, and that is how I got an idea. Where can we learn indoor farming before implementing technology? YouTube is obviously a great platform. There are a lot of YouTube videos which explain, if you are also trying to get into indoor farming and not using IoT, if you want to grow your own greens at home in your balconies, there are a lot of websites, there are a lot of YouTube available. So you can search YouTube and a lot of websites. Google search will give you a lot. So how to connect Arduino board to our system, which software to use? Arduino board is way better to use with Arduino IDE. And when you were asking what kind of IDE, it is Arduino IDE, but I run a dark theme. So I just copy and paste a different theme and change my Arduino IDE to white to blue to black. What to do when we use Raspberry Pi and the pH sensor, which is analog? Well, Raspberry Pi, the issue is Raspberry Pi runs on a 3.3 volt. You have to change all your sensors to step down, matlab to have a voltage regulator of 5.5 output to a 3.3 volt output. Additionally, pH sensor, I personally haven't worked with it. However, I do know that pH sensors cost a lot. It may reach up to 2K or 3K just for the sensor. You can easily get pH sensor codes. You can easily get it and change it according to your wish. How did you manage to connect your mobile app to the device? I built the mobile app on MIT App Inventor. I am a mechanical engineering student. I don't have a background in computer or electronics. This is just my hobby. So anything which has drag and drop feature or which is easy to build is works for me. I built it on MIT and I connected using Bluetooth and Google Firebase. Bold IoT, I just run the Bold Cloud website in the app. How to scale this project over acres of land? Well, as I had said, you use RF modules, you can use radio frequency modules, and you can spread these farms on a huge area. So assume if you're taking a warehouse and you can have up to 10 to 20, and each stack could have one RF module. And then you have one single router which connects from all this. So you don't need to have 10 or 20 Bolt IoTs, you just need to have one Bolt IoT, but you need to have 10 or 20 individual Arduinos. Arduinos collect the data, send it over to radio, and one router collects all the data and shows it on your smartphone or your system. Which software did you use for app development? I used MIT App Inventor. It is an online website for making. How to increase production? Well, again, it depends on crop, it depends on area, and depends upon the environment. How do I use Bolt IoT over Node MCU? Please solve my doubt. Okay, so this is where I have a big soft spot for Bolt IoT. Node MCU, I have struggled a lot and I have literally thrown my Node MCU because it was very difficult getting it connected to the libraries weren't working. So that is why I always have preferred Bold IoT over Node MCU for certain things. Could this be applied for mass scale production? Yes, it is already being applied, and there are many research papers which you can get to know about the cost effectiveness and working of it. Which software do you use for app development? MIT App Inventor. Can we use API to redirect sensor data to a website? Yes, definitely you can use APIs. Again, because I am not very familiar with coding and APIs, I kind of find an easy way. For me, Google Firebase, Bolt IoT, MIT App Inventor, these three have been a godsend. App name is a farm computer. I haven't put it on Play Store. It is just on my GitHub. Using Bolt compulsory? No, it is not compulsory. Again, it is as per your requirement. Just a short difference, Node MCU, multiple pins, Bolt IoT has less pins. However, Node MCU is very basic. You need to code everything and it is difficult running. You'll have issues interfacing with Arduino IDE. You'll have issues with the libraries. Unless and until you sort those, if you sort those issues, it would be a piece of cake. However, for me, I couldn't sort them, so that is why I went to Bold. On the other hand, Bold has everything pre-packaged. Cloud is working well, interface is very swift, web page is already available, 2-3 lines of code, and the project is live. So that is why Bold. I won't say, see, it is a personal preference. I prefer Bold IoT over Node MCU, but I mean, many may have different viewpoints and different experiences. For me, Bolt IoT has worked where Node MCU has failed, but for you, the opposite may or may not be true. Can you share the link of MIT App Inventor? Again, the AIA file and the APK file is on the GitHub. So how to use Google Firebase, MIT App Inventor and Google Firebase. You'll get a lot of YouTube videos. Just type MIT App Inventor Firebase, they'll show it. Node MCU may have pros more than Bolt IoT. However, for me, Bolt IoT has worked. It may not be the same for you or it may not be the same for others. Where did you do the schematics? I did my schematics on Easy EDA. easy EDAs for making PCBs and creating schematics. How can we get in contact with you? Hackster.io or YouTube, you can easily contact me and I'll get a mail stating that certain is contacting and I'll email you. And how do we get data from Arduino to Raspberry Pi? Very simple. Connect Arduino to Raspberry Pi using USB cable, run a serial TTY, serial console. TX, what is TX and RX encode? TX and RX stands for transmission pin and receiver pin. Basically, it is like a UART communication between two devices, UART devices. So here, two devices running on UART connection is your Bolt and Arduino. Can I use Python for coding everything? Yes, you can use Python to code, but you'll have to run some other microcontroller. Can we use other cloud storage systems with Bolt model? I'm not sure about other cloud storage systems using Bolt model, but another cloud example I would say is Firebase. Hope you have loved the session. Hope it gave you great new ideas. Thank you for all your questions. Thank you for your time. Take care, and I hope you really enjoyed.